Welcome to another lesson from Mrs. H. This is actually the last lesson in the unit, and it is just basically proving everything we've already done. So, given lines are parallel, this is the information that we already know, right? Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side, interior, exterior are supplementary. So we're going to write the converse of that because the goal today is to prove lines parallel. So this is the first one, if corresponding angles are congruent, then the lines are parallel. Okay, remember that those two vertical lines means parallel. So basically all we're doing is writing the converse. Remember, with the converse you switch the hypothesis and the conclusion. So the next one would be if alternate interior angles are congruent, then the lines are parallel. Okay. The next one would be if alternate exterior angles are congruent, then the lines are parallel. Okay. So that takes care of our congruent ones. The next ones is if they are supplementary. So if same side interior angles are supplementary, then the lines are parallel. Okay. And for the last one, Colin, hopefully you just said it out loud for me, but if same side exterior angles are congruent, are supplementary, sorry about that, then the lines are parallel. Okay. I know there's 6 lines here, but if you actually look up at top, it was missing a number 4, so that's why. There's only 5 of them. Okay, so we are going to prove lines parallel by using the converse. So first thing we're going to do is decide, are these lines parallel or not? So we have to figure out, and why too, not just because that looks like it. So if we look at the first example, first identify what type of angles do we have. So we're in the same location, so that's corresponding, and they're congruent. So, and we can actually shorthand this, corresponding angles congruent, then lines parallel. So that's all you have to write. So look to see what type of angles you have and then apply to see if it's true. So let's say we did have corresponding angles, but they weren't the same, then we couldn't say that the lines are parallel. Okay. All right, next one. So we have alternate interior angles, and those marks mean that they are congruent. So then therefore these lines are parallel. So we would say alternate interior angles congruent, therefore the lines are parallel. Okay. And then the last one, first decide what type of angles we have. We have alternate exterior angles. So therefore, are they congruent? Yes. Then we would say alternate exterior angles congruent, therefore lines are parallel. Okay, All right, let's go to the next. Okay. And what I want you actually to do is try number 2 on your own and then check your work. So pause the video and then check your work. Okay, so here's what we should have gotten. Same side exterior angles are supplementary, therefore the lines are parallel. So 80 plus 100, they're same side exterior angles, they are supplementary. Then remember that right angles means 90 degrees, so that would be congruent. So corresponding angles congruent, therefore lines are parallel. And then finally, says angle 1 is supplementary to angle 2. These are same side interior angles. They are supplementary, therefore the lines are parallel. Okay. All right, so the next thing is we're going to apply some arithmetic to prove or to show that the lines are parallel. So first things first is you have to identify what type of angles that you have. Okay, once again, here's our transversal, and therefore these are the lines that are parallel. So we are working on the exterior and alternate sides of the transversal. So in order for these lines to be parallel, then that means these angles must be congruent. So we're going to set them equal to each other. So we're going to subtract 8x from both sides. So we get 4 to equal x minus 11, and then add 11. So x equals 15. Okay? And then you can always double check your work and plug these back in and make sure that you get the same angle. Okay? Next example, first have to decide what type of angles that we have. So here is my transversal. Remember, transversal is the one that intersects the other 2 lines. And then here are the lines that I'm trying to prove parallel. So in order for these lines to be parallel, these angles are going to be corresponding angles, and corresponding angles need to be congruent. So once again, I'm going to set them equal to each other. And we get x to equal 12. So basically, decide what type of angles that you have, and then decide if they're going to be corresponding or supplementary. Okay. All right. The next step says find x so that P is parallel to Q. Okay. So here's P and Q. Okay. And it's being cut by 2 transversals, but the transversal we're going to focus on is right here. So there are 2 types of angles we have here that we can use. We can use that these are corresponding, or we can use same side exterior. But if we use same side exterior, we're going to have 2 variables. So it makes sense that we want to use corresponding angles. Okay. Notice that all 3 angles I was working with were on the same transversal. Okay. I can't skip transversals. It has to be on the same transversal. So we're going to make corresponding angles congruent. So I get x to equal 54. Okay. And then in the next example, I want y, so find y so that r and s are parallel. So here's r, here's s, and now this is the transversal that I'm working with. Okay, so we only want to work with angles with respect to that yellow line that I just highlighted. So I can do alternate exterior angles, but again, if I do alternate exterior angles, that's going to cause a problem because I have different variables. But if I use same side exterior angles, then I'm using the same variable. And same side exterior angles add up to 180. They are supplementary. So we get 4y minus 10 equals 180. 4y equals 190, and y equals 95 over 2. Okay, leave it as a fraction. Okay, the next problem asks, can r and s be parallel to p and q at the same time? So in this particular example, can that hold true? Well, if we plug in 54, we're going to get 110 here. So 54 plus 56. And we're going to get 110 here because they need to be congruent. So if that were true, then these two angles would have to be, this would have to be 70 degrees to make it supplementary, right? Because same side exterior angles need to be supplementary. But when you plug in y to this problem, you get you get the angle to be 54.5 degrees. So that would not be true. Okay, so in this particular example, they cannot be parallel at the same time. All right, so this is known as a crook problem. And when you have a crook problem, because there's a crook in it, you basically draw an imaginary line through wherever that crook bends, okay? And it's going to be parallel, because first of all, they told you A and B were parallel. And this line then is going to be parallel to the other two lines. So now I can focus on this being a transversal, okay? And then these two are my parallel lines. So just focusing on what I have highlighted, if this is 100 degrees, what do we know about alternate interior angles? They're congruent. So this also has to be 100 degrees. Okay. We created a line here. Well, a linear pair is supplementary. Supplementary means 180 degrees. Therefore, this is 80 degrees. Okay. But we still need this other part of angle 1. We haven't found that out yet. Well, if we switch now and have this my transversal, and the blue lines, the lines I'm focusing on, again, I have alternate interior angles, so the measure of this angle inside is also 40 degrees. So the measure of angle 1 equals 120 degrees. So when you have a crook problem, just draw a line through the crook that is parallel to the other two lines and then apply our theorems. Okay, so we're going to do two proofs together and then we're going to save the last proof for class. So it says, given 1's complementary to 2 and 3 is complementary to, prove that QT, so QT is parallel to RS. So that means that we need to either prove corresponding alternate interior, alternate exterior angles congruent, or same side exterior, same side interior that are supplementary. So let's go ahead and make our T-chart. So these are the statements, our 2-column proof. These are the reasons. And we're going to start off with the given. So angle 1 is complementary to angle 2, and angle 3 is complementary to angle 2. Okay. So hopefully this is bringing back some memories about when angles are complementary to the same angle, they are congruent. So we can actually say that angle 1 is congruent to angle 3 by the congruent complement theorem. Okay, so let's go ahead and mark that. So we marked 1 is congruent to 3. Well, if you look at where those green lines are, and if I draw in the transversal that respect those green lines, then hopefully we see what type of angles we have, corresponding angles, and they're congruent. So that means that these lines need to be parallel. So QT, or these segments, sorry, QT is parallel to RS, because if corresponding angles are congruent, then the lines are parallel. Okay, so we're going to use, notice how it's important to keep remembering the information we've done from previous chapters, because we use it in order to continue to build our house of proofs. Okay. All right, next example. So let's draw our T-chart. Okay, so it says measure of angle MOP is a right angle. So angle MOP is a right angle. And we have segment RP is perpendicular to segment OP. It wants us to prove MO is parallel to RP. So that's what we're trying to prove. Okay. Well, let's break down some information that we have. So let's break down what perpendicular means. So if RP is perpendicular to OP, that means we have a right angle here. Okay? And MOP is a right angle, so let's go ahead and mark that too. So we say angle OPR is a right angle because it's the definition of perpendicular. Okay? So I can't jump to here and say that MO is parallel to RP, because remember that it says that they're supplementary. It doesn't say that they're two right angles for our converse. It says that they are supplementary. So I first have to show that these two angles are supplementary. Well, once again, this brings back some old information. That angle MOP is supplementary to angle OPR, because if angles are right angles, then they are congruent and supplementary. So now we proved that these angles were supplementary. And if we look at the green, that's where I wanted my lines to be parallel. So this is the transversal that I'm working with. And we just said that these are supplementary because if angles are right angles, they are congruent and supplementary. What type of angles these are? Well, we're inside the green lines, so these would be same side interior. And what do we know about same side interior? They need to be parallel. Or sorry, they need to be supplementary to be parallel, which they are. So we can conclude MO is parallel to RP because same side interior angles are supplementary then lines are parallel. All right, so again, we will do the last proof in class. As always, thanks for tuning in, everyone. See you later.